Welcome to Faith and Science. I'm Dr. John Ashton. You know, sometimes I read articles that criticise Christians for being anti-science. But I think as I think about it, that some of the claims that our young people are being taught, and indeed older people, with regard to evolution are anti-science. We have just so much evidence now that random mutations cannot produce the complex machines and designs of integrated parts all functioning that occur in living systems. And yet the theory of evolution continues to be taught. Mutations can't just random mutations, and mutations are changes in chemical bonding in the DNA that changes the language. And this random blind altering letters in the DNA is not going to produce new functioning parts. It doesn't work that way. When we build machines, and as I mentioned previously, I work for a company where one of our divisions builds quite complex machines that are used in manufacturing and complex robotic type machines. These machines require a number of engineers using known laws of physics to design the components, and the components then have to be made by skilled craftsmen and technician, and there's a tolerance, a very small tolerance of error in a lot of the parts. If the parts aren't machined to very, very fine tolerances, then parts don't fit, or they don't work, or they don't move properly. There's an enormous amount of design that goes in, and also the choice of the particular materials and components that are used in some places, so that there isn't wear or resistant to wear, or resistance to corrosion, or resistance to continuous pressure or hammering, so that there isn't fatigue as different parts knock against one another as part of the process. And also these machines require such things as lubrication and so forth. So there have to be systems in there that provide the lubrication to the moving parts. And of course, these days most of the machines are controlled by computer systems as well, and so there's all the wiring that is involved to the right place and connecting it up to the correct computer. And of course, that's exactly what happens in living systems, and particularly if we get to a system like a human, then it's we have so many complex systems that, again, all connected to our brain, and our brain has to operate these systems. But also, of course, we have consciousness, so we can make decisions and choose. And of course, again, this is one of the whole areas of evolution that there really isn't an evolutionary answer to, because our consciousness, our thoughts are non-material. They're not matter. They don't weigh. They affect matter. Our thoughts affect matter, but our thoughts themselves are non-material. But evolution only deals with material things. Evolution involves chemistry. It involves chemical reactions to produce mutations, to produce new chemical structures that have new functions. We really need to, and listeners to this program really need to write to educators, talk to educators, make educators aware of the enormous problems that there are with the theory of evolution, it just really can't explain how we came to be here. And of course, there's so many good resources out here. There's the Faith and Science program that you're listening to now. And of course, if you want to re-listen to this program or to other programs on this series, remember to Google or go into your search engine, whatever it is, 3ABN Australia, or one word, .org.au, and click on the listen button or the radio, and then the listen button, and there's a range of programs there. There's Faith and Science. There's also another program that I've done, Science Conversations, that is there. And of course on the television, there's the television series. When you go to 3ABN Australia, there's the television series Evolution Impossible, where we discuss in detail some of these aspects. And of course too, if you go to 3ABN Plus, spelt PLUS.TV, and open that up and scroll down, you'll see the different programs. If you scroll down, you'll come to Australia, because there's programs broadcast around the world in different countries. And when you come to Australia, if you then scroll sideways, you'll come to the Evolution Impossible series, and you can watch the whole series there on the internet. So it's important to tell people on your social media pages and friends about this amazing evidence. There are also many other good websites. The website creation.com has thousands of articles with references to the peer review literature that point to the powerful evidence that we now have for creation, for a creator who designed and made the living things that we observe on our planet, and indeed in space. This is a fantastic resource, and also at least many books that are available. If you go into the search engine on that site and enter in 6 days, with a 6 S spelt SIX, then my book, In 6 Days, Why 50 Scientists Choose to Believe in Creation, will come up. And it's free on that site. As you open the link, down the left-hand side will be the names of 50 scientists, all with doctorates, who explain why they believe in creation and reject evolution. There's a huge amount of material out there now. And of course, there are many other sites. The Institute of Creation Research has, or ICR, if you again go in your search engine, Institute for Creation Research, there are so many good articles on that website as well. There's also Answers in Genesis. There's so much good material out there now on the overwhelming scientific evidence that supports the biblical account of how we got here. But one of the things that I'm very interested in is eyes, and the reason for that is that I have closed-angle glaucoma that affects the pressure in my eye. It's essentially not curable. I have to take medication so that I can still see. And so it's fantastic, of course, that we have science and we can build and have an understanding and a knowledge of our eyes so that we can design what we call drugs, which are chemicals that can, again, as I put those drops on my eye, they can help changes in the reactions in my eye, in the physical structure in my eye, so that the pressure can be reduced. But the eye has so many components that require design, and one of those is the tear film. And so the refractive surface of the human eye is most of the surface. There's this tear film which is only about 4 microns thick and has a refractive index of 1.34. Now, this film is a lipid layer that provides a smooth optical surface for the cornea that is vital for eye comfort and visual performance. After every blink, the tear film spreads over the cornea within a second and remains there for about 4 seconds. And so after 5 seconds, the ocular surface will start to experience a breakup of the tear film due to evaporation of the aqueous or water component of tears. And so if the eye doesn't blink within about 5 seconds, the tear film breakup will start to seriously degrade. And in actual fact, the image quality, due to the change in the refractive index, face will actually change. And so when we think about it, tears play that important part. So you just can't have the eye. You've got to have all the tear glands and so forth that produce the composition of the tears. And one of the fascinating things about tears too is that they are powerfully antibacterial. They powerfully protect against infections in the eye. So, and again, we have the unique chemical composition of the tear, which helps, carry out this function and of this particular refractive index and provides this pleasantness. And then, of course, we have to have the muscles that operate the eyelid and so forth. This all has to be coordinated. Now, the cornea itself contributes about 2/3 of the total optical power of the human eye. And so it consists of about 80% of fibres which are filled with collagen, little fibrils of collagen that are only about 30 nanometres in diameter. And they're spaced about every 65 nanometres apart. Now, it's the precise spacing of these little collagen fibrils that produces a regularly arranged matrix that allows light to pass through without experiencing diffraction effects. Now, diffraction is where light is bent as it passes through a fluid. And so this is a really neat trick that makes the cornea transparent without a refractive index, without diffraction occurring. And a slight change in the spacing of the fibrils would cause the cornea to become opaque due to the destructive interference in the light. Now, this precise spacing of these little fibres is, again, it's powerful evidence for design. Random mutations aren't going to produce this spacing because in the meantime the eye isn't going to work. And so when we look at this, it's all this fine detail as we discover, and we're just talking about the eye, again just points to overwhelming engineering with pre-knowledge of the laws of physics and light. See, random mutations don't have laws of, knowledge of the laws of light, of electromagnetic radiation. You have to have someone who has pre-knowledge of the laws of physics to be able to then design a system that's going to work this way. The light bending. And the diffraction, doesn't occur when light passes through a liquid. Diffraction is what occurs when light passes through a very, very small opening. I forgot that. So again, this is, the laws of physics, which are quite precise and, one has to know what these laws of physics are. And so again, my mistake just earlier there as I was talking to you, as I just suddenly remembered, it's refraction occurs when it's passing through a liquid. Diffraction is when it's passing through a very, very narrow slit. And so again, having random mutations have to know that this is part of the design thing, and they can't. One has to have a knowledge of physics, just like I had to have a knowledge of physics to know the difference between refraction and diffraction. And again, this spacing is quite critical for because it's affected by the wavelength of light and that. So again, this spacing and this exact spacing of 65 nanometres allows the light to pass through without diffraction effects. So to me, just this fine detail points to a supernatural creator, designer, and it's everywhere. When we go through, the lens itself, so the crystalline lens contributes about a third of the total optical power of the eye, and of course it helps in the image formation on the retina, and provides for focusing at different target distances, so it accommodates that. Of course, the human eye has a biconvex form with the surface behind the surface in front being about 1.5 times larger than the surface behind. And a relaxed eye is only about 3.5 or 3.6 millimetre actually thick, and has a diameter about 9 millimetres. And of course the lens has no pigment, so it doesn't absorb very much light. So most of that light gets through to the retina. It's interesting, again, the refractive index, and this is refraction is how light is bent when it's passed through a liquid or a transparent solid. The refraction of the crystalline lens actually varies radially, and its largest in the centre has a refractive index of 1.402, and its smallest at the edge with a refractive index of 1.375. And it's very interesting that what they call gradient index lenses, or GRIN lenses, are extremely difficult to manufacture or to find commercially available. But they are very commonly seen in nature, despite the specificity and complexity of the design. So if we only had a single refractive lens instead of a gradient index one, we would be missing about 8 diopters of optical power. So our eyes would be far less efficient. So this is amazing that, again, our eye has been designed to optimise and maximise our optical power. It's interesting that in Genesis, of course, Genesis 1:16, we read that God created the sun and the moon and the greater light that would have been the sun to govern the day and the lesser light to govern the moon. And it's interesting how this fits in actually with the design of the retina. It has, because it has cone photoreceptors for day and rod photoreceptors for night. And so the phototopic day vision, spectral sensitivity or luminous efficiency is about 550 nanometres, whereas the night vision spectral sensitivity is about 570 nanometres. And so our visual system shifts the peak sensitivity from day vision to night vision with an adjustment which is called the Picagini shift. And so again, we find this amazing design within the eyes. Now, the retina contains about 6 million cones, and this cone system has an exceptionally high spatial and temporal resolution due to the packing density of the receptors and the way they are connected to the ganglion cells. It's amazing how they the structure of the eye. These phototopic cones have superior chromatographic and contrast sensitivity. So That's why, humans are able to pick up a lot of very sensitive detail, can do very, very fine work. On the other hand, there's about 120 million rod photoreceptors. So there were 6 million cones, but 120 million rods. And the rod receptors are highly sensitive in dim light. And so this enables us to see in dim light. And this system has the rod photoreceptor system has the ability to sum up the signals from multiple rod photoreceptors and hence achieve spatial and temporal summation. So again, we have to understand that all these signals coming from the cone and rod go to the brain, and the brain has to interpret that information. I mean, of course, we're programmed to interpret the information that we get through our eyes. Of course, the retina also includes horizontal cells, bipolar cells, amacrine cells and ganglion cells. And without these cells, we would not be able to resolve the fine details, which would leave us with blurry images and inaccurate motion detection. So when you think about it, all these different types of cells, right? So we've got the horizontal cells, bipolar cells, amacrine cells, ganglion cells, we've got our rods and our cones. All these structures have to be encoded for in the DNA. And what evolution has to claim is that all these structures arose by random mutations. And I think that, the design is obvious. It's interesting that, one of the proponents of evolution, Dr. Richard Dawkins, has proposed that the retinal architecture seems counterintuitively, it seems to be arranged backwards. But the photoreceptor is located at the back of the retina next to the retinal pigment epithelium, and this architecture is important for the retinal pigment epithelium to replenish the nutrients to the receptor cells, which absorb the light, was not absorbed by the photoreceptors, and it keeps blood-borne pathogens from infecting the eye. So after all, it isn't backward, but very cleverly designed, and also, provides cooling. Of course, one of the other areas of our structure that I'm acutely aware of are our bones. I enjoy running, and I have a number of friends that have had different, joints replaced, knees and shoulders and this sort of thing. And so I'm very keen to, preserve good health of bones. And one of the research projects that I've been involved in recently is looking at the role of vitamin K2, which is an important vitamin for bone health and other parts, and how we can actually increase the intake of vitamin K2 in our diet, because a lot of people, it would seem, don't get sufficient vitamin K2. It's a very interesting vitamin, and it's being discovered it has a lot of health benefits. But our bones are not just rigid structures made up of collagen, as pointed out by Dr. Liliana Endo Munoz, and I've met Liliana. At one stage, she was working in the same department for me as second in charge. She has done a lot of research in the area of bone, and particularly looking at ways we can protect against bone cancer, particularly in children. And she points out that they are living and dynamic organs that grow, change shape and regenerate themselves throughout our lives through a process called bone remodelling. And this process involves development, maintenance, repair and growth, and depends on complex and tightly controlled activities of two major cells, osteoblasts, which make new bones, and osteoclasts, which reabsorb or break down bone. Now, both cell types work with opposing functions, with timely precision and in perfect balance, and their activity is controlled by cartilage-making cells, by osteocytes, which are cells embedded in bone mineralisation matrix, and by extensive regulatory network genes and signalling pathways. And these complex multi-step pathways are driven by a vast array of active proteins, each of which is explicitly coded by DNA for a specific purpose. Now, this is what Dr. Endo Munoz is explaining here, is that we've got an extremely complex design system in bones that involves cells that produce bones and cells that reabsorb or break down bones. And so even just our bones are powerful evidence of intelligent design, and powerful evidence of intelligent design. And the thing is that each step in the signalling pathway involves several of proteins, specific proteins, working in a synchronised and hierarchical manner. The entire process of bone remodelling is tightly regulated at the level of DNA through a variety of chemical changes in the DNA molecule. And in turn, the DNA is tightly regulated by numerous short-coding RNA molecules called microRNA. You know, when we look at the specific detail, we find overwhelming evidence of supernatural design. These processes, these signalling pathways, these control systems, they can't all arise by chance, and if they're not there, it doesn't work. Our bones don't work. And the thing is, these processes are in the bones of animals right early in the development of evolution, because bones require, this is what bones require. We have so much evidence for a creator, as designed in the Bible. And I would encourage everyone, if you haven't read the Bible, buy a Bible, get a Bible, borrow one from a library and read it, and begin to read and know about the message and inspiration that God has given there and revealed about himself as a God who loves us, who came and died so that we might be able to live with him forever in eternity. It's an amazing message in the Bible. You've been listening to Faith and Science. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.